We are graphing linear inequalities on the coordinate plane. Now, let's get started with some of our steps. Number 1, we're going to build our boundary line by using slope and y-intercept to plot a few points. Next, we're going to make the actual line. It's going to be a solid line if it's less than or equal to or greater than or equal to. It's going to be a dashed line if it's less than or greater than. Lastly, we're going to shade the region that represents the solution set. We're going to find this region by picking a point. If the inequality is true, then it's a part of the solution. If the inequality is false, it's not a part of the solution. For this inequality, we have y is greater than 2x minus 4. Our boundary line is going to be y equals 2x minus 4. So let's find the points on this line. Let's start with the y-intercept. That's going to be 0, negative 4. 0, negative 4 is right here. And now let's use the slope to find more points. Our slope is going to be rise over run. Is going to be 2 divided by 1. That means every time we go 1 to the right, we go 2 up. So 1 to the right, 2 up is here. 1 to the right, 2 up, up, and so on. That should be enough for us to graph our line. Now we have our dashed line on here. Like before, we're going to add some arrows. And the reason this is going to be a dashed line is because it's a greater than symbol. There's no equal, and equal would be a full line. Now, which side of the line needs to be shaded? We can do this by checking any point. In this case, we can check the point 1, 1, just for fun. We plug in y for 1, plug in x for 1 as well. We get 1 is greater than 2 minus 4. 1 is greater than negative 2. Because 1 is greater than negative 2 is true, we know that 1, 1 is a solution. As a result, we know that this is the side that part of the solution. Let's just color that. For this inequality, we have 3x minus 2y is less than 6. So our boundary line is going to be 3x minus 2y equals 6. As you can see, you can't really see the slope well, so why don't we make it into slope-intercept form? So let's add 2y to both sides. We get 3x equals 6 plus 2y. Let's subtract 6 from both sides to get 2y equals 3x minus 6. We divide both sides by 2, get y equals 3 over 2x minus 3. So we know our y-intercept is going to be 0, negative 3. And we know that our slope is 3 over 2. Now, let's get started. We have 0, negative 3 as a point. And now let's use our slope to get more points. Rise over run is 3 over 2. So that means we go 2 to the right and we go 3 up. Right over. We go another 2 to the side. We go 3 up. That should be enough for us to graph our line. In this case, we have a less than symbol and there's no equal to, so we know we're going to get a dashed line. Now we have our dashed line. Let's add arrows and let's figure out which of the two sides needs to be shaded in. In this case, we can plug in any point, like always. Why don't we plug in 0, 0? We have 3 times 0 minus 2 times 0 is less than 6. 0 minus 0 is less than 6. 0 is less than 6 is correct. So we know 0, 0 is going to be a valid solution. So we know we're shading this side. You can choose any points to plug in to find out which side you should shade in. But I like to use 0, 0 commonly because it's pretty easy to plug in. For this inequality, we have y is less than or equal to 3/4 x plus 2. So we know the boundary line is going to be y equals 3/4 x plus 2. So that's what we're trying to graph now. So let's start with the y-intercept. When x is 0, y is 2. So let's plot that point. We have 0, 2 right here. Next, let's look for a few more points based on the slope. Our slope is 3/4. So rise over run is 3/4. That means that if we go 4 to the right, we go 3 up. So let's go 4 to the right and let's go 3 up. And let's also do it on the other side. So if we go 4 to the left, we go 3 down. That brings us here. Now, let's graph our line. Now we need to find which side we should mark our solution set. We can do this by plugging in any point. If it makes the inequality true, then we know it's part of our solution set. Why don't we plug in 0, 0 right here? Because it's a relatively easy point to plug in. If we do 0, 0, we know y is 0, less than or equal to 3/4 times 0 plus 2. 0 is less than or equal to 2. That's correct. So we know 0, 0 is part of our solution. As a result, we know our solution is going to be everything on the bottom. We've arrived at our final challenge question. We have y is greater than or equal to 2/3 x plus 2, and y is less than or equal to 1/4 x plus 1 graphed. Where do they intersect? As you can see on the graph, they intersect right over here. Now, let's solve. As you can see, they intersect at this boundary line, which would be when y is exactly equal to 2/3 x plus 2, and y is exactly equal to 1/4 x plus 1. As a result, we know that 2/3 x plus 2 is equal to 1/4 x plus 1 when they intersect. Now, let's move this over. 2/3 x minus 1/4 x equals 1 minus 2. Now we have the x's on one side and our number on the other side. Now, let's find a common denominator. It would be 8/12 minus 3/12. X equals -1. So we have 5/12x equals -1. So we know that x equals -12 divided by 5. Now, we know y is this value and also this value. So we can plug it into either one. Let's plug it into the 1/4 x plus 1. Doing that, we'll get y equals 1/4 -12 divided by 5 plus 1, which is equal to -12. Divide this, so it becomes -3/5 plus 1, which is 2/5. Our final answer is that it intersects at -12 divided by 5, 2/5. And that's the end of today's video. Thank you so much for watching.